Okay, ladies and gentlemen, here is the lab that we're going to do, and I'll give a little bit of explanation. I'm going to, first of all, assume that you have read the pre-lab and have done the prediction question. If you have not done the prediction question, please stop the video now, go read the pre-lab and the question and the prediction question, and answer that before we move on. Essentially, what we're doing with this lab is trying to figure out kind of a special aspect of work in a specific circumstance. So what I'm going to be doing here is I'm going to be pulling this cart, naturally. And there's about 50 little things that are going to go wrong every trial, so just hang with me. We're going to pull this cart up this ramp, and we're going to measure the amount of force that it takes to cause this cart to go up this distance. So this distance is a distance that we're going to have to record, except I've already put those distances in the data table for you. We're going to start at a distance of 1.2 meters, and we're going to change the distance by 10 centimeters every time. But what we're doing is right here at this point, this high point, we're always going to the same high point every time by pulling this. And what we're going to do is we're going to see what happens to the force that it takes to pull this object. Your task right now is to record the force in every trial, and there's going to be a little bit of pause in between each trial because I'll have to change the angle, and so I will let you know when to take the force reading. So one of the things I have to do right now is switch the screens so you can see the data screen. Okay, so you can still see the lab going on in the upper corner. And then what we're going to do is you are going to record the force that is in this upper left corner. Now, I threw the graph on there just because, I wonder, maybe you can't read that now that I think about it. So I'm going to make that bigger. There. So the negative sign is just a direction, and I actually tried to change that to make it positive, and it wasn't letting me. You can drop the negative sign because the force sensor only reads in the negative direction. So first thing we're gonna do is we're gonna pull this up here the first time, and you'll see that the force kind of changes quite a bit, but it doesn't matter. So right there should be your force reading. It takes 2.5 newtons to pull the force up for the first 1.2 meters, okay? So now, what we're going to do at this point is we're going to change the angle every time, and you're going to see me getting in front of the screen, and I apologize for that. Maybe I can sneak around. And so I'm going to change the angle. So now I'm at 1.2 meters, okay? And you can already see that the force has changed, but I'm going to pull the object up again, okay? So at 1.2 meters, we're at 2.7 newtons, okay? And we're just going to keep going like this. So I'm going to change the angle again. Hopefully I don't knock everything over. Okay, so now we're at 1 meter. Okay, and you can see the force has already increased. The thing is, I'm only going up to this height every time. And even though I'm not actually even pulling up to that height, okay, it doesn't matter because that force really doesn't change a whole lot. So we're going to call it right there. We're going to call it 2.9 newtons. Okay, increasing again. Now my distance that I am applying the force is 0.9. And so I'm going to pull this object up, and I'll kind of balance it right in the middle. We slid a little bit. Hold on, I gotta, oh, I'm sliding. Let me get this back up to 0.9. So there's 0.9. So 3.3. Okay, I'm just gonna stay here. There's 0.8. 3.7. There's 0.7. 4.3. And there's 0.6. And we'll call that 5.0. Okay, so those are all the forces that you need to write down. And essentially at this point, now you just need to go read the rest of the lab, answer the questions on that assignment. Oh, I kind of need to stop the video.